I'm going to do a deep dive on a new patent-pending erasure coding technology invented by Quantum. This invention greatly enhances the economics of object storage. We call this new technology 2D erasure coding. Essentially, the patent application describes a unique approach to efficiently manage objects on tape while providing greater protection and performance than was previously possible with tape-based solutions. And the reason we had to invent 2D erasure coding was so that we could leverage the economics of tape within ActiveScale. So let's look at how 2D erasure coding works. Let's say you have some objects, and these objects are in ActiveScale, along with many others. And ActiveScale has identified some of these objects as ready to transition to cold storage. This is where the 2D erasure coding process starts. The first thing that happens is the objects are aggregated into multi-terabyte size containers. So that container is made up of a sequence of objects in their native form. No coding has taken place yet. The container is then split into some number of segments. In this example, for simplicity, I'm using 4, but that number can be as high as 20 depending on the selected durability policy. Each one of these segments then go through erasure coding, and we end up with some number of data shards and some number of parity shards. The same happens to each segment. This is erasure coding in a single dimension, the vertical dimension. Now let's apply erasure coding in the horizontal dimension. You can think of the vertical dimension shards, either data or parity, as the data shards for the horizontal dimension. And from those shards, we can calculate parity. So that original container, consisting of hundreds or thousands of objects, is now protected with erasure coding in 2 dimensions, the vertical and the horizontal. And this makes so much sense for tape. The result of the 2D erasure coding process is some number of equally sized segments, 6 in this example, and each of those segments is written to tape in a single stream. So multiple terabytes and thousands of objects protected and written to tape with minimal tape mounts. Now what about efficiency when reading from tape? Remember, before any coding took place, that container was a sequence of objects. So when we get an object from tape, we don't need to retrieve the entire container, just the part of one segment that contains the shards that make up the requested object. And from those shards, ActiveScale will reconstruct the original object. And this is the norm. Very close to 100% of the time, we'll get the object back in this manner. But let's consider a case when the tape that contains the required shards has some minor damage. One of the shards is unreadable for some reason. Remember, that vertical segment has inline parity, and ActiveScale will use that parity to recreate the object and then repair the segment in the background. Now what if that tape was severely damaged, or even missing, some condition where ActiveScale is unable to repair using the inline parity? And this is very much the exception. In the rarest case, ActiveScale will use the horizontal parity to recover a severely damaged or even recreate the segments in the case of a missing tape. Once the segment has been reconstructed, the object is returned and the remaining segments are reconstructed in the background. So let's take protection to the extreme. Another technology we can leverage is a redundant array of independent libraries, or Quantum's rail architecture. Without 2D erasure coding, there really is no practical way to do this. A single copy of your data protected with 2D erasure coding spread across multiple libraries. Now let's look at some of the benefits that come with the rail architecture. The obvious one, of course, is redundancy. If you were to lose a library or have a robotics failure, you still have the redundancy required to access your data. And this level of redundancy comes without the expense of a multi-copy strategy. Additionally, the rail architecture enables parallelism, the ability to leverage multiple robotic sets in a parallel fashion greatly reduces the bottlenecks and in turn improves performance. The number of libraries participating in the rail is not fixed. Additional libraries can be added as you grow, and as you add libraries, the net result is higher durability and higher performance. A quick review of the benefits of 2D erasure coding. Thousands of objects are written to tape with just a few tape mounts. Objects can be retrieved with a single tape mount. It provides superior protection and durability without the expense of a multi-copy approach. Vertical in-tape erasure coding protects against tape damage. Horizontal across-tape erasure coding protects against severely damaged or missing tapes. The rail architecture enables across-library parallelism and protects against robotic failures. For more information on ActiveScale object storage, visit our website.